Yep, so I'm going to tell you a little bit about the tools that we're building at DeSci Labs for scientific publishing. And I can't help myself, but I have to start with a little rant about how publishing currently works. So the scientific publishing industry, as you probably know, is a highly concentrated oligopolistic market, highly profitable for the publishers. The 5 largest publishers increased their market share from 55% in 2000 to over 85% in 2023. At the same time, the number of published articles increased from 1 million per year to over 3 million a year. This is an industry that is netting more than $12 billion of revenue every year just for publishing scholarly articles. And the big 5 that dominate that market, they enjoy profit margins of about 40%, which is actually higher than some of the most innovative tech companies in the world, such as Google and Apple. So this is, of course, fantastic news for the publishers, but it's really bad news for us as scientists and for society and the taxpayers that ultimately have to fund the bill for that. Now, it doesn't end there. It's also that the business models that we currently have in scientific publishing are highly problematic. So we basically have 2 models. Friederike already mentioned it earlier. There is the pay-to-read and the pay-to-write model. So pay-to-read is problematic because with these paywalls around scientific knowledge, we're actually excluding the vast majority of mankind from access to scientific knowledge. And this actually includes the taxpayers that have been funding these public goods. And in some cases, it even excludes the scientists themselves from accessing that literature. The pay-to-write model, which came about when the open access movement started and people wanted to get rid of these paywalls, the pay-to-write or the APC model, author publication charges, is problematic for a different reason. So it's not only that the publication charges for publishing in scientific journals are ridiculously high, so it's often something between $1,000 up to almost $12,000 if you want to publish in Nature open access, for example. So, but that's not even the key problem. The key problem is that it creates a really perverse incentive for publishers to basically accept everything that they're getting, right? Because every time they reject a submission, they're actually foregoing revenue. So that has a baked-in incentive for lowering the quality standards. And I'm not saying here that all open access publishers have low quality standards. That's certainly not the truth. But what we have seen is that with the rise of these APC models, we also saw a rise in predatory journals and an increase in scientific articles and publications that simply do not deserve the name. And then, of course, at the core of this value proposition of this entire industry is the fact that the publishers say, well, this now has been peer-reviewed, it has been evaluated, the quality has been checked. Now, but that happened on the back of scientists that are doing the work and are not getting paid for it. So there was recently a study that came out which estimated the value of the time that scientists spent on peer review for journals. And they estimated that every single year, scientists are donating more than $1.5 billion to publishers in terms of unpaid peer review time. Now, you're not going to be surprised that for editors of scientific journals, the biggest problem is finding referees. Well, duh. But it's also that the actual act of how we're currently doing peer review is leading to doubtful quality, and it's a complete black box. So in most cases, peer reviews are not accessible to anybody except the editors. You don't know what has been evaluated, you don't know what the outcomes were, you don't know why certain things were accepted or rejected. It's a total black box. So what we need is, first of all, we need to have journals that are not owned by the scientific publishers, but by the scientific community. Put the scientists back in the driving seat. We need an alternative business model to APCs and paywalls that specifically rewards high quality validation and curation services, because that's what's actually valuable. And then we need much more transparency around these validation and curation services. What was exactly evaluated, and that needs to be part of the scholarly record to the extent that this is possible. And then finally, we need to create rewards and incentives for referees for fast and high quality work. And that's exactly what we're trying to build at DeSci Labs. The great news is that we're not starting at zero, so we already have a infrastructure for scientific communication that we call DeSci Nodes, where you can already share your work with the public without paywalls and publication charges. All the content that ends up on that application is actually stored on an open state, peer-to-peer network. And that basically means that on this application there is no data silos. People cannot monopolize the data anymore that you've created. Also the metadata is all out in the open. And it creates the possibility for data sovereignty, because anybody in the world can actually start up a server that participates in this network, and they can decide what content is actually valuable to them, and they can pin it and basically contribute to the storage and accessibility of that knowledge for the future. The infrastructure that we built is specifically not just for manuscript, it's for rich, versionable research objects. So what's a research object? It's a collection of all the artifacts that are relevant for describing a research project. So that's not just the manuscript, it's also data, it's code, it's preliminary versions, it's basically a version history that shows the progress from the early stage ideas to the final output. And all of the files and research objects on this network get an automatic, free, persistent identifier, which is based on content address storage. So it's actually derived from the content itself. And that basically provides protection against link rot and content drift, both very substantial problems in the scientific record. It also makes all of these artifacts machine actionable. And it basically is a system that is fair by design. And one thing that we started introducing is what we call attestations. So attestations are there to highlight and to validate characteristics of research objects. So think of them like metadata on top of the scientific record. So these are things like open data, open code, these types of things. And really cool, also on this infrastructure, you can do what we call programmatic publishing. So with programmatic publishing, using the Nodes.lib library, you can do things like automatically importing content that you have on other servers, bring it on this peer-to-peer network, give it persistent identifiers, make it machine actionable. And you can also automatically publish data the moment that it gets generated. So this is interesting for things like satellite images, weather stations, spectrometers, all these types of applications where science is producing massive amounts of data, and we can literally make them not only accessible, but also persistent, findable, fair the moment that they get generated. Then we have an early version of communities that review, validate, and curate research objects on their feed on the DeSci Nodes app. And all of this is available as open source software using the AGPL 3.0 license. So that's really important because that's a license that is a so-called copyleft license, which means that anybody can fork the code, can rerun the code, under the condition that that code is also going to be made available open source. So that means that the technology is going to be around independent from whether we as an organization are around. It also means that this technology cannot be bought. So this is very similar to the approach that the Public Knowledge Project and open journal systems are using. It's exactly the same license, actually. So a primitive for evaluating knowledge in the system are these attestations. And you can think of them as metadata or simply as digitally verified badges for research. And they're ultimately verifiable claims about characteristics of a research object that are claimed by the author and that are then verified or rejected during the peer review process. And each claimed attestation has a unique persistent identifier that is linked to the research object, so they automatically become part of the scientific record. And every community or journal, they can basically define their own attestations or decide which of the already existing attestations they're using. And this opens up the possibility for structured peer review. So rather than having peer review in a black box, we now have the ability to say, well, here are the characteristics that we want our referees to check. And then we have a transparent track record of what came out of this, what was checked by whom, and so on and so forth. And claiming an attestation basically opens a dialogue between the authors and the referees in the context of the research object. So here's an example. This is a research object where the author claimed an open code attestation. And you see here on the left, this is the attestation, and then it opens up this dialogue between the authors and the referees, which ultimately led to the verification of this attestation, and all of that is accessible. And also really, really cool. So if you put your research on DeSci nodes and you claim an open data or open code attestation, and that attestation gets verified by an independent third party, you get an automatic record written into your org ID record that basically gives you credit for making that data set or that code publicly available. So this already works today automatically, so the only thing that you have to do is like put your things on nodes and claim these attestations. So as I said, so we have early stage version, a beta version of communities that can validate and curate research on this infrastructure. And although it's really early stage and a lot of functions are still missing, we have a number of interesting use cases emerging. So first of all, there's the Journal of Risk Science, which is basically using this infrastructure as a support to their traditional publishing system. So they basically want to encourage their authors to not only publish their manuscript, but share data and code and have this transparent track record of how they ended up with their results. So they encourage their authors to create these research objects in our infrastructure and then to submit them to that journal so that editors and referees can actually check all of these things. And that's a way how they actually improve the quality and the open science approach of their journal. Another interesting use case is actually from one of my junior colleagues, somebody at the Max Planck Institute in Berlin. So I'm doing a lot of research in behavioral genetics, and we published a paper together, and this junior researcher then had this idea of starting a community called the Behavioral Geneticist on this platform, where the idea is that junior researchers in that community from all different sorts of places come together and they basically give each other feedback on early stage research with the attempt to help each other to make their research better and to improve their publication chances. And this seems to fill a gap where you would think, well, this is a supervisor's job to give you feedback. But in reality, the supervisor is often very busy, may not be available to give answers to all the questions that the PhD students have. So this is a possibility for junior researchers to just help each other to become better scientists. And then finally, we have organizations that are starting to showcase their research that they're doing, such as Block Science. So it's an infrastructure where organizations can not only have all the research that they're doing in one place, but where they can also basically do their research in the open and be basically subject to public scrutiny, which is actually highly desirable to some of these organizations. So if you want to start such a community, it's very simple. You go on our website, DeSci.com, you click on journals and you click on create a community, and it's free, and there you go. Later this year, we are planning to launch an infrastructure for actual open access scientific journals on this platform. So this will have all the capabilities that you would expect from a publishing system. It will have an editorial management system, suggestions for suitable referees, DOIs, of course, indexing capabilities for the major databases in science. And the people that are running that, they can basically choose if they want to run this journal on their own hardware or if they want to use a hosted solution by us. And for all the communities and journals that are emerging, they will have the option to participate in the incentive layer that we're planning to build out. So the incentive layer, this is going to be basically the final piece of our infrastructure that we're trying to build. So this is currently in an R&D phase, and the goal here is that we want to create a market mechanism that incentivizes high quality validation and curation services of scientific content. And this will be the alternative to the APC and paywalls that I was talking about earlier. And particularly, we also need to solve the free writing problem for peer review here, where because we don't have any rewards for referees, there is also, it's hard to find referees, long waiting times, low quality. And a lot of the peer review is actually getting done by a very small part of the scientific community that is basically doing that public service, whereas a lot of researchers are consuming more of that peer review than they're giving back. That's a problem that we can and will solve. And of course, in terms of design principles, we will try to make this system as resistant to strategic behavior and abuse as possible, while enabling a plurality of value and quality definitions. So we basically want to create an open playground for mechanism design where the best systems can then evolve. So one of the things that this incentive layer will do is it will create the possibility of having a token economy for peer review. And the idea here is that with a very simple token system, we can actually codify this concept of reciprocity that we have in peer review in the scientific system. So the idea really is that if you publish, you need to get peer reviewed, so everybody needs to give a little, everybody needs to take a little. We can make that very explicit by basically giving people tokens for performing fast, high-quality peer review and requesting them to give tokens whenever they request such evaluation services. And there is no need for money to change any hands as long as people are behaving as good citizens, because we can have basically an onboarding mechanism that gives all new participants that join the system for the first time a small token endowment that will allow them to operate in that system without needing any money. And the journals and the communities can then define the attestations that they require and the prices, the token prices for these attestations. And the prices and the attestations they can vary quite a lot between communities. So this is what we can leave up to the system to decide. So very importantly, it's not going to be us who are deciding what is good quality or what is not. This needs to evolve naturally from the ground up. And once the token is actually tradable, it allows specialization of agents. So you can imagine that those people that actually really enjoy peer review and that are really good at it, they will probably accumulate a lot of these tokens that they don't need to get their own work reviewed, so they can actually sell these tokens for an additional income. While other people that actually don't want to do peer review at all, but they just want to have quick and high quality reviews of their own work, they can go on the market, buy these tokens, and then basically pay for these services.
Two questions, actually. The first one is OrcID, you mentioned.
Yep.
Is that necessary in order to use the system?
No, it's not necessary. It's a nice to have, so we recommend it because it automatically gives us the possibility to add credit to the author's track record, but you can just as well log in with any email address or with a wallet if you have one.
That's good, because OrcID, by virtue of being a credit system, can be used for censorship, which is very dangerous.
Yeah.
The second question is about IPFS, which is, as we know, not incentive compatible. Not everyone has hardware resources to donate, or hosted servers or whatever. So why is it that you chose that as the basis for your model, as opposed to simply allowing people to host their own? P.S. You already said that they have their own hardware or hosted service provider anyway, so why don't they just use that or one of their own websites to publish it and then just reference the ID and get a proof that things have been done? It seems like IPFS is a strange choice.
Actually, so it's a good question, but there is a very, very good reason. So the reason is that with IPFS, we're getting content address storage, which allows us to have persistent identifiers for every file, for every research object that is being stored on that data on that network. And the peer-to-peer nature of that network actually gets rid of data silos. So these are two main benefits that we get from that: persistence and peer-to-peer networks, which protect against data silos.
Thank you, Philipp. So first of all, thanks for the presentation. I think you have a great product, and I love that you make it very simple. So it's not that it's overloaded with functionality. So I think it's really great. My question is, you have a platform, so it's really critical that you have enough users in the platform. You know, you need the reviewers, you need the scientists, the people who write publications. So what's your strategy in reaching out? Do you think it's a good idea to have like a top-down or a bottom-up strategy for that?
So I think we will probably need both. So what we will do is in July, we will actually start a new service that I think will be very attractive to a lot of scientists, where they can actually create submission packages for the journal of their choice, where they just create a research object on this platform and upload the data and the code, and then they basically get a manuscript with a cover page that has a direct link to all the available resources and the badges that were claimed. And that's going to be the very first thing that anybody who opens that manuscript will see. They will see this is not just a manuscript, it's actually coming with data and with code, and it has a transparent track record. And the idea is that having that type of thing will actually increase people's chances to get published in the journals that they care about. So we do have survey evidence from editors that this is exactly what they're looking for. So that should help. And then the communities and the journals, of course, they bring in all their researchers and their content. So that's also going to be really critical for this to emerge.
Okay, cool. Thank you.
Yeah.